Hello YouTube and welcome back to the channel. Today we are going to look at the fundamentals of how binary works. So we'll be looking at bases, so what makes up the bases. We can be looking at counting, so the general structure of counting, and we're going to be looking at the overall mathematics of how to add the different bits together. So the first thing to note in effect is that when we talk about base 2, the base means that you have 2 to the power of a number. So that is what we mean by base 2. 2 to the power of 0 is equal to 1. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. And 2 to the power of 3 is equal to 8. What this means, in a nutshell, is that we are only going to be counting up to 2 numbers because it's base 2. Those numbers are 0 and 1. And 2 to the power of 0 is equal to 1, as mentioned previously, which means that the numbers are not going to repeat within a given sequence. So in other words, we're going to count to 0 and then 1, and then after that we will reset back to 0, as we will see shortly. If you look at 2 to the power of 1, 2 to the power of 1 is equal to 2. And this means that base 2 shows that we will only be counting up to 0 and 1 again. And each number is now going to repeat twice because 2 to the power of 1 is equal to 2, as mentioned previously. 2 to the power of 2 is equal to 4. So each number is only going to be represented once within each character set, meaning that we're only counting up to 0 and up to 1. And it means that each number is going to repeat 4 times within the given character set. 2 to the power of 3 is equal to 8. So once again we are dealing with base 2, so each number is represented as either a 0 and a 1, as mentioned previously with all the others as well. But it means that each number is now going to be repeated 8 times within each sequence. So let's go ahead and let's have a look at counting and how this is represented. So 2 to the power of 0 is equal to 1. So what this means is that each character is only going to be represented once. So there is 0 and there's a 1, and then you notice how 0 is reset again, so 1 resets back to 0 rather. So we have 0 again, and then a 1, and a 0 and a 1, and a 0 and a 1. So in other words, you don't see a 0, 0, 1, 1, 1, 0, 1. You're looking at specifically a sequence of 0, 1, 0, 1, 0, 1, which will continue all the way to infinity. 2 to the power of 1 is equal to 2. So this means that each number is going to be repeated twice. So there we have 2 zeros and there we have 2 ones. 2 zeros, 2 ones. And so this carries on indefinitely. 2 to the power of 2 is equal to 4. So it means each number is now going to repeat 4 times. So let's have a look at them. So we have 4 zeros and 4 ones, and so this will continue on indefinitely. So 4 zeros, 4 ones, 4 zeros, 4 ones, and this carries on forever. 2 to the power of 3 is equal to 8, so therefore each number is now going to repeat 8 times. So let's count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then after that you would have 8 ones. It's important to note that we're still counting here. In other words, what we're doing is we're actually still incrementing by 1. So if we put the decimal numbering system next to it, what it means is that if you look at the number 8 is represented as 1, 0, 0, 0 in binary. Number 7 is represented as 0, 1, 1, 1 in binary. And number 6 would be represented as 0, 1, 1, 0 in binary. So we are still incrementing by 1, we are still counting, so the rules don't change. It's just the numbers that look a little bit strange. The next thing to note is just to look at the mathematics of the bits themselves. So 0 plus 0 is equal to 0 in binary. 1 plus 0 is equal to 1 in binary, and 1 plus 1 is equal to 1, 0. So to put this into context, if I have a 1 and I add another 1, what is happening here is 1 plus 1 is resetting back to 0, and we then carry the 1, and 1 plus an imaginary 0 in front of the number is equal to 1. So that gives us 1, 0 when we add two 1's bits together. Thank you, YouTube. I hope you enjoyed the lesson. I hope you found it constructive, and I look forward to seeing you all again soon.